This is the Chapter 6 review for geometry. It says, determine if the following figures are polygons. Circle Y for yes or N for no. A polygon, remember, is a many-sided figure with straight line segments, no segments that cross, no curved segments. And so as we look through these first four, we see that number 1 is a polygon. Number 2 is not because of the curved segment there. Number 3 has an added segment that is not connected, so it's not the enclosed figure, so that is a no. And then number 4 is a yes, it is a polygon. Looking at number 5, it says determine if the following figures are convex or concave. Think of concave as something like a cave, you go in. So if you see something that kind of goes in, or it looks like the shape has been sucked in, then it's concave. It's convex would be if you were to go to one of the vertices and blow air into it so it pops out, everything's popped out. The official definition says that there is no segment, as I draw these segments here, 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 no line I should say, that crosses through the interior of the shape if you were to continue it, like this one would over here. If I continue through there, it goes right through the shape. So that's the official definition. So we can see very quickly and easily that number 5 is convex and number 6 is concave. Number 7 and 8, it says determine if the following figures are equilateral, equiangular, regular, or none. Looking at number 7, equilateral means all sides are equal in length. We see that all sides are marked as equal here. Now, since all 3 sides of this triangle are marked as equal, that means all 3 angles are also equal. So this first shape 7 is equilateral and equiangular. And if a figure is equilateral and equiangular, we say it is regular. So this one is regular. And the next shape, not all sides are marked as equal, so it's not equilateral. It's definitely not equiangular. We can see that the angles here and here are different. One's acute and one's obtuse. So it can't be regular, so this falls in the category of none. Number 9, it says find the values of the variables. So we have a parallelogram here, 4-sided quadrilateral with opposite sides parallel. So we know that we could set the opposite sides equal and then go ahead and solve. So on something like number 9, these 2 sides here and here, you can set them equal and solve. If you do that, you get x equals 9. So x equals 9. These angles here and here are equal. Opposite angles are equal in a parallelogram. So z equals 47. And then we have the y equals 7x statement there. So if we know x is 9, then y must be 7 times 9, or 63. All right, the second one here. This is an isosceles trapezoid. It's isosceles trapezoid because it has 1 pair of parallel sides, 4-sided figure, 1 pair of parallel sides. Here and here you see the parallel side markings. And then these sides over here and here are marked as congruent. So that means these angles here and here are supplementary. So if I add those 2 up, 2y plus 3y is 5y, negative 10 minus 49 is minus 59. Those have to equal 180. So those 2 angles there and there, not 180. Take that back. We got an isosceles one. So they add up to, or actually are, excuse me, let's fix that. It would be here and here, so it would be these 2 that would be supplementary. These 2 down here and here are actually equivalent. You can see that they're opposite equal sides of the trapezoid. So we can set 2y minus 10 equal to 3y minus 49. We'll use the supplementary clause on the next one and erase all this garbage here. So once again, we have these 2 on the very bottom, here and here, we can set equal to each other. Solve that for y. if you subtract 2y over and add the 49 over, you end up with y equals 39. So y equals 39 in this case. If y equals 39, this angle on the left that I circled right here is 2 times 39, that's 60. 78 minus 10 is 68 degrees. And therefore, z is going to be 180 minus 68, which ends up being 112. So z equals 112 degrees. All right. Oops. A little too much there. All right, looking at the rhombus here, number 11, we have rhombus is a four-sided figure, a parallelogram to be exact, with all four sides congruent. And we know that in a rhombus, the diagonals meet right here at right angles, so we know that x is 90 degrees for that reason. We also know that the diagonals bisect each other, splitting these two I circled, or splitting that diagonal in half, making the two things I've circled equivalent to each other. So we can set 2y minus 1 equal to 15, 2y equals 16, y equals 8. So diagonals are bisected, and also diagonals are perpendicular. We call those perpendicular bisectors. So we use that to set up and solve for x and y. Number 12, we've got a kite here. So in a kite, we know that these two pieces are congruent, and these two down here are congruent. Nothing is parallel. It's a four-sided shape with no pairs of parallel sides, but we do have adjacent sides that are congruent. We can set 10y minus 4 equal to 71. So 10y equals 75. Therefore, y is 7.5. If y is 7.5, x can be found by plugging 7.5 in here, right here. So 4 times 7.5 is 28, 20, 30. 30 minus 3 is 27. All right, let's move on into the always, sometimes, never true stuff. All right, it says a parallelogram. It says decide if the following statements are always, sometimes, or never true. It says a parallelogram is a square. So a parallelogram is kind of up above it, includes squares within it. So a parallelogram is a square if all the angles are congruent and all the sides are congruent. So that would be a sometimes true. An isosceles trapezoid has two parallel sides. An isosceles, what that is actually asking is, or stating is, an isosceles trapezoid has two pairs of parallel sides, is what that should say. That is never true. A trapezoid, by definition, is a quadrilateral with only one pair of parallel sides, so that is never. And a rhombus is a trapezoid. That is a never. Actually, I'm thinking that this may have been intended to say exactly what it says. So in isosceles, I think I had one of each on these. So an isosceles trapezoid has two parallel sides. That would be one pair of parallel sides, and that would be true by definition. So that is an always. I think that's what it's saying. It is true that a trapezoid only has one pair of parallel sides. I think that's what it's saying is two parallel sides. In other words, one pair. So that isn't always. Pretty sure I had one of each on this. All right, number 16, it says, what is the area of the rhombus? What is the area of the rhombus? Okay, it says a rhombus has diagonals of length 18 and 80. So the diagonals are 18 and 80. If it's a rhombus, the long diagonal would be the 80. The short one would be the 18. I've got to take a moment to try and calibrate this. Okay. Difficult to write on here when it's not calibrated. So the long one is 80, meaning each of these would be 40 and 40. And then the other one is 18, meaning each of these is 9 and 9. And if I were to take and separate out one of these guys, let's just take that guy, we would have a right triangle. It's a right angle right there. This is 9. This is 40. So the hypotenuse is going to be 9 squared plus 40 squared equals, call this r squared. If you solve for r, you will get r equals 41. That's actually over here. That's the side length. So r equals 41 is the side length. The area of this thing. One way to find the area would be, let's go ahead and move this over here. Just a moment here. So here I have this right triangle. We'll draw it one more time here. Definitely not to scale, but that's 9, that's 40. So we said, okay, r squared has to equal 9 squared plus 40 squared. That's where we got the side length, r equal to 41. And for the area, we know that the area is equal to, if you see this as 4 triangles, this shape is made up of 4 triangles. Redraw it one more time. That's better. You see the 4 triangles in there. There's a right angle right there. And the base and height of the triangles are 9 and 40. So we had a 40 here and a 9 here, 40 here, 9 here. So we have 9 times 40 and divided by 2 would be one of them, and then of course there are 4 triangles that make up that rhombus. So if I cancel the 2 and the 4, then I end up with 2 times 40, which is 80. 80 times 9 is 720 square meters. So it just amounts to finding the area of those 4 triangles that make up the rhombus. Once again, the side length is found by using the Pythagorean theorem. And it's actually a Pythagorean triple. All right, number 18 is dealing with the mid-segment theorem. The mid-segment theorem says that the mid-segment right here is equal to the average of the bases. So we take an average of the bases, and that will give us x. So 10 plus 16 is 26, divided by 2 is 13. All right, last couple problems here. Number 19, it says find the areas of the following quadrilaterals. The area of a trapezoid is equal to 1/2 the height times base 1 plus base 2. It's just like the area formula for a triangle, only a trapezoid has 2 bases. So here we have 1/2, the height 4, base 1 is 5, and base 2 is 9. Half of 4 is 2. 2 times 14 is 28 square inches. And over here, we'll write it up here, 28 square inches. Number 20, we have area equals base times height for a parallelogram. It's the same as it is for a rectangle. So area in this case is equal to 8 is the base. The height is 4. This number is in there just to trip you up. That's not a height, nor is it a base. It's the length of that side there. But the area in this case is 32 square meters. Hope this is helpful. Thanks.